All right, here we go. We are taking on angle and arcs today, so just a little mixed practice. So first up here, if I look at my diagram in number 1, I can see that R and S, they're both inscribed angles. Their vertex is on the circle. I can also see that right here, they have the same intercepted arc. So if I trace up like that, and I trace up like that, they have the same intercepted arc. So I know that inscribed angles are going to be congruent because they have the same intercepted arc. So right here, this angle has to be congruent to this angle right here. So I can build an equation where I make them equal to each other. So I have 9x plus 2 is equal to 12x minus 13. So now I'm just solving for x. So I'm going to take away the 9x from each side. 2 is equal to 3x minus 13. Add the 13 over. 15 equals 3x. Divide each side by 3. So x equals 5. Okay, but that's not what the question's asking for, right? It's not asking for x. It's asking for the measure of r. So let's go ahead and plug in. So the measure of r right here would be 12 times x, which is 5, right? Just solve for that. And then plus 2. So I get 60. Oh, I just wrote that wrong. Not plus 2. Minus 13. Minus 13. All right, so 12 times 5 minus 13. So I have 60, take away 13, and I get 47. I could have also plugged it in for the measure of s. It would have been the same thing. So here I would have had 9 times 5 plus 2. And just to confirm, since they're the same, right, I should get 47 this way as well. And I do. So the measure of r is 47. The measure of s, also 47. Okay, on to the next one. So in problem 2, I'm trying to get to x. X is right here. So I want to scope out my diagram and look for some little clues. So one thing that I notice right here is that this angle, this inscribed angle, its vertex is on the circle. So I know that if I double it, I can get to its intercepted arc from here to here. So if I double 86, I get 172. Okay, so then I just have to figure out, well, how do I get to this arc? Right here, mark it in green. How do I get to that arc? So I can see a relationship right here where this angle has a measure of 70 degrees. Its vertex is inside of the circle, and I have one of the two arcs. So let's say that I temporarily call this one y, right? I want to solve for y so that I can get to x. So here I know that the angle that's 70 degrees is equal to the average of the two intercepted arcs. So half of 44 plus x. Okay, so now I want to solve for x, so I want to clear my fraction, multiply each side by 2. So here I have 140 is equal to 44 plus x. Take away the 44, and x equals 96. So right here, we're at 96. Okay, but again, that's not what I'm solving for. I'm trying to solve for x. So to get to my final answer, I'm taking the 172, and I'm taking away the 96, and that leaves me with 76. That's my x value that I wanted. So 76 degrees would be the measure of x. Okay, next up. Slide that up. Okay, so right here, I'm asked for the measure of ME. So I'm trying to solve for this span here to here. But I can't get to it right away. I have to first solve for this smaller arc right here. So let me call that, I'll call it x. All right, so if I'm solving for x, I know the angle right here with its vertex outside of the circle. I know that its measure is 36 degrees. I know that the larger of the two arcs is 90. I want the smaller of the two arcs. So I know that that angle that's 36 is equal to 1/2 the difference between the two intercepted arcs. So here's my equation. I like to clear my fraction, so I'm going to multiply each side by 2. So I get 72 equals 90 minus x. Take away the 90. Negative 18 equals negative x. Divide the negative 1 away, and we get that x is equal to 18. So right here I have 18 degrees. Okay, so I solved for what I was able to solve for, but now I have to solve for what I wanted. I want this arc right here. So I know that all the way around my circle is 360 degrees. So if I take the 360 and I take away the 90 right here and the 18 right here, that gets me 252 degrees, and I have to split that 2 ways. So I get 126 degrees for this arc right here and this arc right here. So again, whenever I see that I have chords here and here that are congruent, I know that these arcs have to be congruent as well. These chords cut off the same portion of the circle, so the arcs must match also. So the measure of ME, minor arc ME, has to be 126 degrees. All right, next up, find the measure of arc BAD. So I'm using a 3-letter notation. That means we're talking about a major arc or a semicircle. Okay, at the very start of the problem, we were finding the indicated variable, angle, arc, or segment length in circle O. So if O is the center of the circle, then we should know that this segment right here is a diameter. And any diameter splits our circle into 2 perfect half circles, 2 semicircles. So if I look at this part here as a semicircle, 180 degrees, I can see that those chords are splitting it up into 3 equal portions. So I take that 180, split it 3 ways, and I get 60 degrees. So each of these smaller parts, these arcs, have measures of 60 degrees. Okay, this was a semicircle 2, also 180. But now, again, I have to go back and see what the question was asking me to do. And it was saying, find the measure of BAD, major arc BAD. I know that now because it's spanning from here, wrapping all the way around to here. So that part that I have in green, I have to add the 180 and the 60. So if I add 180 and the 60, I get 240 degrees. All right, next batch of 2. Let me slide it up. You know the drill. All right, so here we see that we have a circle that is inscribed inside of a triangle. And I'm trying to find the measure of all of those angles of a triangle. And I know that any triangle, those angles have to add up to 180. So I have to build off of what is marked, and I see that a bunch of these minor arcs, they are marked. I see this one here at 120, this one is 124. So the relationship that I have to remember is that when I have a circle, and I have a tangent and a tangent like that, then I know that the angle right here and the minor arc right there, they have to be supplementary. They must add up to 180. So to remind you of why that works, let me just bring a little post-it like that. So let's say that I draw that relationship out one more time. So I have a circle, I have a tangent, and a tangent like that. So let's say that I told you that this arc had a measure of, let's make it 100 degrees. Just like that. Then I know that if I connect from this point of tangency to this point of tangency, like so, I'm really making an isosceles triangle. I know that this angle will be half of that 100, so has to be 50. This angle will be half of the 100. This would have to be 50 as well. So again, here's my isosceles triangle. Those two base angles have to both be 50 degrees. So what's left over, right? Got to be the 80 degrees that goes right here. And then I see that my triangle adds up to 180. And I see that the angle and this arc, they are supplementary. All right. So if I can see that relationship, then I can easily get to my missing parts. What I would probably do first is just fill in my missing arc right here. So all the way around my circle is 360 degrees. So if I take away the 120 and the 124, so 360, take away 120 and 124, that leaves me with 116. Okay, so that missing arc is 116. And then I want to work my way around the circle, and all I'm doing is I'm going to take 180 minus 120. So right here where Z is, right, that's got to be 60. (180 minus Y), I'm sorry, minus 124 will get me Y. So 180 minus 24 will get me Y. So that gets us 56 degrees. Okay, and then 180 minus 116 will get me to X. So X has to be 64 degrees. All right, next up here, I'm giving you a visual, and I'm saying that the measure of BKC, that is 52 degrees. So let me label BKC right here. BKC here is 52 degrees. And here I'm naming the circle K. So K is the center of my circle. So I know that if 52 is my central angle, its intercepted arc will also be 52 degrees. And I know that if I have congruent chords, I know that their arcs have to match too. So that means that right over here, gotta be 52 degrees, also 52 degrees here. So their arcs must also be the same. Okay, so now as I look at my circle, I can see that this notation is telling me that these three angles, they have to be congruent too. I know that all the way around has to be 360. So I'm going to start by saying, what is 360? And take away the 352s. Take away the 352s. So if I take 360 and I subtract the 352s, I'm left with 204 degrees. So I know that this angle plus this angle plus this angle has to sum to 204 degrees. So I need to split it three ways since all of those angles are congruent. So if I split it three ways, I get 68 degrees. So I have 68 degrees here, here, and here. And all of their arcs, they must match also. So I have 68 degrees here, here, and here. All right, so now I'm asking for the measure of arc EF. That notation tells me minor arc. So right here would be 68 degrees. Okay, ACE, so a major arc, ACE from here to here. So I could add all these up, get 240, or I could subtract here and here from 360 and get the same. 240. Okay, DFC. So if I'm looking at DFC, so this really big major arc, probably take 360 and subtract the 68 and get 292 degrees, of course. All right, let's flip the page or pull out the second page. Let me get mine in the right position. Right there. Okay. So next problem, number 7. So here I want to find the measure of LM. So let me mark where LM is, right here. Okay, but I actually don't have enough information to get there, so I'm going to have to solve for a different part first. I can solve for this part right here that I'm marking in green. I'm going to label that Y. What I want, I'm going to keep that as X. All right, so if I'm solving for Y, I can do that because I do know the angle right here, and I know the larger of the two intercepted arcs. It's that small one that I want. So if I go after Y first, I know that the angle of 40 is equal to 1/2 the difference between those two intercepted arcs. So here's my equation. 40 is equal to 1/2 of the difference between 168 and Y. So here I'm going to clear my fraction by multiplying each side by 2. So 80 is equal to 168 minus Y. I'm going to take away the 168 from each side, and I get negative 88 is equal to negative Y. Okay, I'm going to divide away the negative 1 from each side, and Y equals 88. Okay, but again, it's not what I needed. It's not what I asked for in the end. So I'm still one more step away from getting to my unknown X, the measure of arc LM. So now that I know that this arc is 88, I know that this angle right here is 78. I want this other arc. And I know that when my vertex is inside of the circle, the angle is the average of the two arcs. So I can build an equation where 78 is equal to 1/2 of X plus 88. Okay, I'm going to clear my fraction, multiply each side by 2. I get 156 is equal to X plus 88. Take away the 88, and X is equal to 68. So 68 degrees. And that makes perfect sense because remember that if 78 is an average of two numbers, I know that it's equidistant to those two values. So 78 plus 10 gets us 88. So 78 minus 10 will get us the 68 degrees. So that's another way of doing it if you like that more intuitive approach instead of building an equation. It does not matter to me. All right, next up, number 8. I use the diagram of circle B. So if I'm naming it circle B instead, that's my center. Line R is tangent to circle B at point T. So this is the point of tangency. It's that one location where it's touching the circle. And I should know that a tangent line and a radius are going to be perpendicular. So I'll sneak in that little right angle right there. BT, we're told that that is 2. And BS is 1, so not perfectly to scale, but it's 1. And WT is 5. Okay, so now I have to connect the dots. So first I'm asking for BA. So BA is just right here. So BA right there, well, that's just a radius of the circle. I know that any radius in a circle will be congruent to any other radius. My radii, plural, they're always going to be congruent. So that's an easy one, right? It's got to be 2. BA is 2. It's a radius. I already defined the radius as 2. All right, so now I want the measure of AN. I want this whole measure right here. So I know that a radius, when it is perpendicular to a chord, that's what that notation is telling me, that chord gets bisected. So here and here are congruent. Let me give it a double tick mark so you don't mistake it for my 1 right there. Okay, so now I see, I got a right triangle. So let me picture that right triangle, maybe right about here. So here's 1, here is 2. I'll call this part x. So I can solve for x. I know how to use the Pythagorean Theorem. We use it all the time. So 1 squared plus x squared equals 2 squared. So 1 plus x squared equals 4. Take away the 1, x squared equals 3. Solve by taking the square root, and we get that x is plus or minus the square root of 3. But we know it's a length, it's a measurement, can never be the negative, so I'm only interested in the positive. So x is the square root of 3. So right here is the square root of 3, and then same with right here. But I'm asking for an. I'm asking for this guy right here. So if I'm focusing on that part that I've just marked in yellow, I have to add root 3 and root 3. So I really have 2 root 3's. These are like terms. They have the same radicand, the number underneath the radical. So I can go ahead and combine them to make 2 square root 3. All right, last thing I want BW's. Let me mark that in a different color. So I want Y. So I see, it's another right triangle. We have lots of right triangles here. So I know that this longer leg is 5, the short leg is 2, and I want the hypotenuse, so I'm calling that Y. So 2 squared plus 5 squared equals Y squared. 4 plus 25 equals Y squared. So y squared equals 29. Take the square root of each side. Right, 29 is prime. I'm not going to be able to simplify that further. So I just get plus or minus the square root of 29. Algebraically, I got the 2 answers, but I'm only interested in the one that works, which is the positive square root of 29. All right, let me slide up to the last 2. So here, these are just throwbacks, right? Ones that I know that students have always struggled with. So I wanted to do a quick refresher here too. So find the length and the area of the sector. So length of the arc here, and then the area of that shaded slice of pie right there. So if I start with my length is a portion of the total circumference. So the measure of the arc in degrees to 360, right? Just the ratio of arc to circle. And then I multiply that by the circumference, 2 pi r. So then I'm just plugging in. So I know that that right angle means 90 degrees. So 90 to 360 times 2 times pi times a radius of 6. So my length is going to be 1/4 of 12 pi. Right? The total circumference, the total distance around my circle would be 12 pi. I want 1/4 of it. So if I take 12 and I divide it by 4, I end up with 3. So 3 pi. 3 pi, whatever units we're working with. Okay, then I want the area. So the area of the sector, right? It's just a portion of the total area. So I need to know, well, what is that portion? What is the ratio of arc to circle? So measure to 360 and then times the total area of pi r squared. So the area of my sector will be 90 to 360 times pi times 6 squared. So I'm looking at 1/4 of 36 pi. So 36 divided by 4 gets me 9. So 9 pi. So 9 pi, whatever my units are, squared. Okay, so last but not least, find the area of the shaded region. So here I always have to think, well, what's my master plan? So I'm going to start off with my master plan and say, okay, well, to get to that shaded little sliver out here, I'm looking at, let me just write area of shaded region first. It's going to be the area of the sector minus the triangle. So here is my sector right here. That's the whole slice of pie. And then we remove that hollow triangle, and what we're left with is that shaded region. So now I need to figure out, well, how do I get to my sector? So the area of my sector is the ratio of degree measure of the arc to the full circle times the area of the circle, pi r squared. So here I see, okay, well, there's a radius. The radius is 6. So I actually know that another radius here, well, that's got to be 6 also, because I know, again, that my radii, plural for radius, my radii are congruent. So if that's an isosceles triangle, I know that the two base angles here and here, they have to match. So this has to be 60 degrees, which really means that that vertex angle right here, it's got to be 60 degrees too, right there. So then I see, oh, it's really an equilateral triangle. It must be an equilateral triangle. Let me write that. Okay, so it must be an equilateral triangle. So let me just sketch out the triangle. When it's equilateral, I actually have two choices for how I want to solve for its area. So I could use 1/2 base times height, or I could use 1/2 the apothem times the perimeter. Both of those options work. I would probably use just 1/2 base times height. So let me write that out here. My triangle would be, area is 1/2 base times height. Because I know that if it's equilateral, all sides are 6, and then I can easily just cut it down the middle and make two 30, 60, 90 triangles. So let me label this as 60. Here would be 30, 30, and 60. Okay, so if I'm trying to get to the height, I know that that 6 is being split into two equal parts, so I can go ahead and make this a 3 and this a 3. The height I want. It's where my arrow is pointing. I want my height. So I should know that if I view this as a special right triangle, the short leg is x, the longer leg is x times the square root of 3, and the hypotenuse is 2x. So I already know the short leg is 3, so the longer leg will be 3 root 3. Okay, so I have everything that I'm going to need. So sector first, 60 to 360. Times pi times 6 squared. So I want 1/6 of 36 pi. So I get 6 pi. Okay, for my triangle, I'm doing 1/2 the base of 6, the height times 3 root 3. So that's just like saying 1/2 of 6 times 3 times the square root of 3. 1/2 of 6 is 3 times 3 is 9, so 9 root 3. So I'm taking my sector, subtracting my triangle, so 6 pi minus 9 root 3 is my answer when I write it exact. I'll always take it exact unless I specify otherwise. And since it's area, we always have to write it in terms of units squared, square units. All right, that's our lecture today. I hope you guys have a wonderful rest of your day.